Hi there, welcome to today's video. In today's video, I will be showing some of the basic image processing commands or some of the basic stuff that you actually need to know if you want to work with images. So these are just the basic tools that you should know when working with images. Today I will cover cropping of images, resizing of images, saving those images. I mean, you can't just save them as a figure like if you are like making typical Python plot, which is what people are used to, where you could just save the figure. If you say that way, you tend to lose information in those images. So there's a special way of saving images that you retain those information. I will show you how to save those, and it's optimized in this way so you don't take much space. And then I will show you how to calculate histogram for your images. I will show you how to do thresholding on those images, and then I will manually add noise to the image and show you how to denoise those images. If you know at least this, it's like you have a pretty good idea of like at least 20% of what you should know about working with images for you to be proud and consider yourself as someone that is good with working with images or doing image analysis. And so as usual, let me start by giving this a title. I'll just call this basic image processing tools. I mean, these are soft tools, not really hardware. Okay, and so the first step as usual is to import required libraries. So we import the needed libraries, and I have already typed them down here so that I don't waste much time. And so if I click on there, these are the stuff that we need. We'll be using OpenCV to read the image and do other operations that are saving the images. We'll be using NumPy to do some operation on those images like the cropping, and we may not really need NumPy to crop, or at the end of the day we may not really need NumPy for anything, but yeah, it's good to have it handy. We're using Matplotlib to do the plotting, and there are other utils that we need from scikit image called the random noise, which I'll be using to add a noise, and I'll be using the threshold and auto for like the thresholding exercise. Okay, so I will go ahead and import all of them. And so the first line of code is to actually load the image, and I have it in my head here. And so here I'm just like reading this image that I have in this folder called data, and it's called Econ Every Point. It's an image I took at University of Connecticut, and I'm reading this image as a grayscale even though it's a colored image. So if I plot it, it's actually a colored image. I took it with my iPhone, and I'm converting it to gray scale since I'm not doing any fancy kind of analysis with this, but this will be sufficient for this particular task I want to accomplish. And I'm calling this particular image. So if I run this now, if I check what is my image will contain data. So these are the intensities in this image. I could even go ahead and plot it just to give you a feel of what the image look like. If I do plt.imshow, again, if you've watched my videos already, you should already be conversant with some of these commands I'll be using. So that's how the image look like. Here I'm plotting it with the default color map. We could change this to grayscale, black and white image using the gray. And to silence this stuff that is showing here, I know to be annoying for some people, is plt.show. If you do that, or you attach a handle here, then that will go away. This particular one, let's go, so that goes away. So this is how the image look like. This is the ocean, and this is the sky. There are light clouds here. There's a lighthouse in the ocean there, and these are boulders. These are big rocks, and this is grasses. So there's a walkway where I stood here. I took this image just to orient you. You don't have to know memorize any of those. So that's the first step. First step is reading image. To read image, you just need cv2.imread. So the image read, and you can read it as this, or you could also read it as a color RGB, BGR, whatever. Okay, I could do a detailed tutorial of different ways that you could read image if that is helpful to anyone, but I think this should be pretty straightforward. Just use imread, and then provide a string or the path where your image is, just your image, And then you could even change this to and type it 0 here, and it will read it as a grayscale image. And what I mean by grayscale is it just has a single channel of colors. And so if I check the shape of this particular image, if I do the shape and I pass in the image, we should have it 2D. So it's a 2D. So this is telling me how tall the image is, and this is how wide the image is. Usually it's y comma x. So that's the shape, as you could see from here. If you want to see how much bright this is, see these borders are, you have to add a color bar. And so you could just do plt.color bar, and if you run that, then there will be a color bar here now. And if you want to make this figure to look the same size as this particular color bar, then you have to play with the fixed size. And so you could do something like fixed size is equal to, and this is actually a tuple, so I could give you maybe a 10 by 7. That's the horizontal command, the vertical. I mean, it's getting big, but it's not doing that. So let me just reduce this to 8, and let's make this a 5. And there we go. And so we have been able to make this look more nice. And you could add the axis, the label to the y and the x, but this is not important for this particular one. You could also silence this and labels on the axis, but I think I could do that in other videos, or check my previous videos, you might find it in one. So next, let's crop this image. So next exercise will be cropping. So let's do cropping of the image. So I'll render the cropping. And so to crop this image, basically you want to select some indices that you want to keep. I mean, if you want to be more fancy, I don't know the exact person that is watching this video now, but if you're advanced and you want to do something more fancy, you could even use G input, such that you just click on this image, and by just clicking on the image, you are able to crop those coordinates of where you click. Let me try something. This is for zooming in on the image. Maybe I already have it here, or maybe not. Maybe I have it already. So if I notice that this particular image, I cannot zoom it. There is nothing to zoom in on the image. But if I run it now, I'll be able to zoom on the image. Sadly, okay, it's outside here. Okay, so now this showed up by using this magic, the matplotlib widget. And so now I can zoom on this image just to show you what the image looks like. So that's a section of the image. These are the borders that I was talking about. And you could zoom in as much as you want, okay? And you could always go back home with that. All right, so let's crop this image. And so what I was saying was, you could make it fancy. Notice down here that the coordinates are showing somewhere around here. That's useful for the cropping. You could also like just write it such that you use G input, so that when you click like this and drag this way, then it's able to just crop within the small box that I'm creating here. So it's able to like fetch this automatically and crop the image for you, so that after instead of just zooming this way, it gives you the cropped image that looks of this size. Basically, I wouldn't be doing that in this video, but I think that's a fun project. I don't think that's readily available in Python. If someone could do that, that would be very handy for other people. And so let's just crop this image to this level. And so to do this, we need to know our x coordinates and our y coordinates, okay? And so let's provide those. So let's provide those as x1. Our x1 is equal to 1400. Let's scroll from 1400. Our x2 is 2800. I'm just reading from what we have here, okay? 2800. And our y1 is 1200, and it's going to 2400. 1200, and our y2 is 2400. Okay, now we have the coordinates. And so what we want to do is, let's call this image that we want to crop to be cropped, and we're operating this on the image, which is what I read the image as. And in here, I'm going to pass in our x, y. Remember I said it's y, x, And so I would say that it should go from my y1 all the way to y2 command. My x1 should go all the way to x2. So I just pick my image, and for the y coordinates I'm selecting just within this range of y's from here to here, which is just this range I'm showing you above here. And for my x I'm also selecting the same. Remember, one comes before the second, so it goes from 0 all the way to the highest. Okay, and we could go ahead and plot this image. So I'll just copy this command, plotting command. I'll be copying it around just so that we inspect what we're doing. Okay, and we're going to change this image to cropped because that's a new name we gave it. And if we run this now, then it gives us just this image that is equivalent to what we showed up here. So that's how to crop image in Python. I hope that is useful. Let me know if you have any question. Let's go to the next exercise I want to do. The next one is we want to actually resize this image. So let's do a resize on this particular image. And I'll make this as a markdown. Again, this code will be available on my GitHub. Please follow me on GitHub too. And don't forget to subscribe if you have already started getting information from this particular video. And so to crop, I just need to use OpenCV. So let me just, sorry, I'm doing resize now. To resize, so I'm going to call this resized. And my resize I will use from CV2. There's a command here called resize. So let's just use that, okay? And in the resize, it's expecting the image that we want to resize. Should we resize the original or the crop? Let's go with the crop since we've already started manipulating on the image. And the new shape that we want to recrop it into, provide it as a tuple here. And so maybe I want to crop this particular image. It's big, so I want to resize it to maybe a 128 by 128. Okay, so basically I'm taking this crop image and I'm changing the size to be of this. And again, if I copy this plotting command and notice that this image is going from here to above 1000 and it's going from here to above 1000. Now need to change to something like this. That's basically what we want to achieve here. It's handy this way when you want to like compress your image and save space on your computer basically. And so we want to change this to our resized, since that is the operation we perform now. And if we run this, this will give us a new image, and this image is 128 by 128, and this is how it looks like. So what he did was it basically kind of like costing the image. So that's why we're losing some of the details here. So we actually did some sort of averaging for a bunch of pixels. So if you pick a bunch of this and represent it as a single pixel, then you sort of come up with something that looks this kind of noisy. But I think you get the point. You don't have to do it excessive. You could make it a 512 if you want to. So you could make the shape of this image 512, so just half of the original, sorry, half of the crop image. So if we run that again, then you have this change to 500 and 500 compared to the 1000 and 1000 here, and you still have information in there. So I just wanted to show you that so that you know what you're actually doing. So this is like an example of like where if I'm just using this particular image for machine vision, I'm just using to train my module, then I don't really need to keep this image as big as it is. I could resize it and still retain this information, and I'll be able to still label this to be rocks and this to be water and that to be sky. Why this maybe 9 megabyte, this particular one will be in kilobyte. Okay, so you're actually getting in space. I'm talking too much, I know, but it's good to like explain some of this stuff so that you actually know when to apply some of this stuff that I'm teaching you here. Cool, let's go to the next one. So after you've done all this operation, say you want to save this image, this is how you save. So let's do save, and let me know if this is not big enough on your screen. In the next video I could increase it if that is the case. You should be able to see, I think so. I'm using a big screen, that's why I'm worried. Okay, and so to save the image you just need to do CV2. So OpenCV has this im write, so im write, just image write, and then you provide the name of the image that you want to save. Let's save it in the same place that I got the other image, in my folder called data, and let's save this as test save .jpg or png or whatever. And then you provide the data that you want to save. We could choose to save the resized, since this is the most recent operation performed on the image, and then we could paste that there, and then we could run that, and it tells us true. And if we go into this folder, we will see the image here. So you click it, and that's the image that we just saved. Notice that there are no axes showing on the image compared to that if you use a figure save, then you have all those bunch of stuff to deal with. So that's the saving command. And the next operation is to threshold this image and noise the image, and then followed by I'll do all of them together now, so I'll speed up stuff. I'm getting close to my 20-minute mark that I want the video to last for. Okay, so first we want to again, I wanted to do a histogram, so let me do the histogram first. So let's just call this rest of the task that we want to perform. I will do all of them here, and then just plot it at the end. Okay, so to do histogram, we could call this hist to be equal to the hist. There is a cv2.hist, and the hist actually has a calculate, and then has a hist, and the h is capitulator in case you run into issues. I think at some point I had issues like that. And then in here we want to provide what we want to do the hist on. We want to do the hist of that particular image that is called resize, and we're providing it as a list. Okay, and then we'll provide the range. So it should go 0, the minimum, and then we could do a none, and then we could do the max to be 255 intensity, and then we'll provide a range 256 to 55. Let's just do 256. Sometimes since it's going from 0, that will take care of itself, so 0,256. okay, so that will calculate our histogram for us. I'm not going to plot it, but it has calculated the histogram. Maybe I should just plot it. I'm running seriously behind time, so if I do plt dot figure, and if I do my plt dot plot, and in here I passed in the histogram. If I run that, then you see that's how the intensities are distributed. So those are the counts, and this is how you go across one of the axes of the image. The brightness values. So these are the brightness values going from dark. These are dark, contribution of dark, and these are somewhere in gray, and this is the white. These are the rocks, and this is part of the ocean and the ground in the image. And so that's how it's actually distributed. So that's how you plot the histogram of your image. Next, let's do some cleaning of this image and end the video. And so also I wanted to do thresholding, so let's do thresholding. So to do the thresholding, you just need to apply threshold. Let's just call this threshold value. First of all, calculator has threshold value, and we could do this using the threshold also, and then we'll provide what we want to calculate the threshold upon is the resize, the image called resize, and then we could now threshold our image, and then we could call this our trash image, and this will be a tuple. In a tuple, let's do the resized, where the resize is greater than, so this conditioner is greater than the trash value, which is what we calculated above there. Then we could change the type of this and tell it to be as type, and the as type, let's tell it to be an NumPy unsigned integer 8, NumPy unsigned integer 8, and we could scale it back to the 256 or 255 rather. So if we run that, you complain about the unsigned, okay, there's no, sorry, integer int. I dropped the n in the wrong place. Okay, and then let's just proceed and do the noising, and then I'll upload it once. It's already 20 minutes in this video long. Sorry about that. And so for the noise, we'll just create our noise, and let's just end the video here. I'll do the rest in the next video. So let's just plot this particular threshold image, and we'll end it here. So I just want to copy the plotting command and plot the threshold image, and if I do that to be the threshold image, if I run that, then that's how the image looks like. So those values that are past threshold values, so basically here we're able to isolate the borders from every other thing, the water and the land. Here we could easily extract all the borders. So that's that for this video. Sorry I couldn't do the bilateral filtering, but I will do that together in the next video. Please subscribe if you found this useful, and also share with others that are learning Python. And if you have any suggestion of what I should do next, please drop it in the comment. Until next time, bye. I remain Binarizing.